Alright guys, I'm back. Welcome to Unit 5 of College Algebra Trigonometry. Today we're going to be starting our unit all dealing with the trigonometric identities. And this is the bottom of that reference sheet that you guys have been allowed to use on your tests and quizzes. All of those relationships that look kind of scary, but we're going to go through. We're going to talk about each one and how and when to use it to help you solve problems. So the first set of identities that we want to consider are the reciprocal identities. These ones you have already worked with before. So things like sine and cosecant, these are reciprocals of one another. Cosine and secant are reciprocals, and tangent and cotangents are reciprocals. So keep in mind, a reciprocal is that number, and to find the reciprocal you take 1 over that number. Okay? If it's a fraction, you can flip your fraction. It's kind of the shortcut way to remember how to find the reciprocal. The next set of identities are the quotient identities, which you've looked at as well. We've defined sine and cosine as y and x respectively, and tangent was equal to y over x. So tangent is equal to sine over cosine. And if cotangent is the reciprocal of tangent, as we talked about in our last set of identities, then it would make sense that we could just flip our x and our y to get the reciprocal identity. Our next set of identities are the Pythagorean identities. If you remember from geometry, and we've used it a lot in units 3 and 4, a squared plus b squared equals c squared. That's Pythagorean's identity. Well, the same thing will apply within trigonometry. If you pick any angle on our unit circle, so this will have a radius of 1. I'm going to say this is our 30-degree angle, or pi over 6. So this would be square root of 3 over 2. This will be a 1/2, because our cosine-sine pair here is labeled as such. So if I go through and I take my sine value and I square it, so that's the one in blue, and add that to my cosine value, the x value, squared, it should equal 1 squared because of that right triangle. So in simplifying, 1 squared is going to be 1/4. Square root of 3 over 2 squared, you're going to square this, you get 3. Square the 2, you get 4, equal to 1. I hope we all agree that 1/4 plus 3/4 is equal to 1. So our identity is true. Sine squared plus cosine squared equals 1 will occur at any point along your circle. Okay? Sine squared plus cosine squared equal to 1 does not have to be a special unit circle angle. It can be any angle, and that will be true. So then we have to ask ourselves, how do we get these other two forms of the Pythagorean identity? Well, these ones, to be quite honest with you, I don't memorize them. I remember the fact that sine squared plus cosine squared is equal to 1. If I want to go from sine squared and turn it into a tangent squared, I could divide by a cosine squared. Then I'd have to divide this by cosine squared and this by cosine squared. Well, sine squared over cosine squared is going to give me tangent squared. Cosine squared over cosine squared gives me 1. 1 over cosine squared is the reciprocal, so we're going to get a secant squared. All you got to do is divide everything through by cosine. Likewise, if I start again with sine squared plus cosine squared is equal to 1, and this time I divide everything through by sine squared. Sine squared divided by sine squared, that's going to give me 1. Cosine squared divided by sine squared will give me cotangent squared. And 1 divided by sine squared gives me its reciprocal, cosecant squared. So there's really no need to memorize these two. Well, there's no need for you guys to memorize any of them because you get your identity sheet. But it does help to understand where they come from and how you can derive them on your own if you need to. Alright, our next set of identities are the cofunction identities. So sine and cosine, tangent and cotangent, and secant and cosecant. So they're not the reciprocals, although tangent and cotangent serve as both. These are our cofunctions. The reason that these identities hold true is if I pick a theta measurement, so let's say this is 60 degrees, which would be pi over 3, okay? The cosine of pi over 3, which is 1/2, is equal to the sine of pi over 2 minus that 60 degrees. Well, pi over 2 is 90, pi over 3 is 60. 90 minus 60 we'll say would be the sine of 30. And I think we all remember the sine of 30 is 1/2. 1/2 is equal to 1/2. This will be true any way you look at your triangles when you have your co-functions, because you're talking about the two different acute angles within your right triangle. Even and odd identities, if you want to think about them from your unit circle, if I pick some theta measurement, okay, so I'll put theta here in the second quadrant, and I would have this sine value, the y. I could draw negative theta, so going backwards, down here. My y values would be exactly the same in size, but one would be positive and one would be negative. With cosine, if I pick some angle, we'll go with this one. Here's my cosine, right, the x value. And if I draw that same angle but going backwards, I would get that exact same cosine value. So in this case, positive, positive. In this case, positive, negative. And you can explore the other ones on your own. So now we want to use these trig identities to evaluate our trig functions. So we're looking for the remaining functions, knowing that tangent is square root of 3 over 3, and cosine is negative root 3 over 2. So I think the first ones that are the easiest to find would be the reciprocal functions. So the cotangent of x is going to be equal to 3 over the square root of 3, because tangent and cotangent are reciprocals. We want to rationalize that. Always rationalize. Simplest answers. Those are going to cancel. Cotangent of x will be equal to the square root of 3. Alright, so 1 down, 3 to go. The next one, we'll take cosine and we'll find its reciprocal. Recall that the reciprocal of cosine is secant. So I can take this fraction and find the reciprocal. Again, I'm going to rationalize. Don't forget to keep that negative sign. So the secant of x will be equal to negative 2 rad 3 over 3. Alright, and now I'm kind of stuck because I got tangent and cotangent, cosine and secant. So I want to think back to my identities and see if there's any way that I can relate tangent and cosine. We know that tangent of x is equal to the sine of x over cosine of x. That's our relationship. And conveniently, although intentionally, sine of x is what we're still looking for. If we could figure out what the sine of x is, we would have enough information to then take the reciprocal and find the cosecant of x. So I'm going to get sine of x by itself by multiplying both sides by cosine. So now I've got the cosine of x times the tangent of x is equal to the sine of x. Well, I know cosine was negative square root of 3 over 2. Tangent is the square root of 3 over 3. And that's going to leave us to find sine of x. Negative root 3 times root 3 is going to just be a negative 3. 2 times 3 is 6. That's all going to simplify to negative 1/2 is the sine of x. So now the last thing I need to find is the cosecant, which will be the reciprocal of this right here, so -2. So I just use all of my identities to help me find the remaining trig functions. Yes, you have the option of drawing a triangle, but sometimes using identities just makes it a little bit quicker without needing to draw the picture. Alright, use trig identities to evaluate the remaining trig functions. So looking at this little symbol right here is just a Greek letter, okay? Just means an angle. This right here, according to our identities chart, would be equal to just the sine of phi of that angle. Okay, so I have these two that I'm working with. Well, we know the reciprocal of sine will give us the cosecant. We know the reciprocal of cosine gets us the secant. So then our last thing we need to find are things dealing with tangent and cotangent. Again, I think our easiest relationship there is that the tangent of x is going to equal the sine over the cosine. When you divide fractions, you want to multiply by the reciprocal. So tangent of x is equal to 3/5 times the reciprocal of our denominator. These things are going to cancel. Tangent of x equals 3/4. And if tangent of x equals 3/4, then its reciprocal function will be equal to 4/3. Sorry, I jumped a page there. This right here, something I want you to consider is that our sine value was positive. Our cosine value was also positive, which means our angle is taking place up here in quadrant 1, because that's where both sine and cosine are going to be positive, which then makes sense that all of our other trig functions are also positive, because all trig functions are positive in the first quadrant. If we look back here, we've got tangent is positive, cosine is negative. That's going to occur down here in quadrant 3, because our x will be negative, but our y over x will end up being positive. So when you look at the rest of your functions, cotangent is positive, and everything else is negative, just as it should be for quadrant 3. So, to summarize, think about what quadrant you're in. It'll help you justify your answers. Understand your identities. If all else fails, you can draw a triangle. Trigonometry is the study of triangle measurement. So if you're ever stuck on these problems, it wouldn't hurt to draw a triangle out. So for instance, on the last one where it tells you that cosine was 4/5, I believe. Yeah. You can go ahead and draw a triangle that has a cosine value of 4/5. Sine also is 3/5, and you could go through and find your trig values that way. But we want you to practice using the identities so you get more comfortable with them. Also, my last little note to you is that if tangent is equal to sine over cosine, then tangent squared will be sine squared over cosine squared. You could also write tangent to the third would equal sine to the third, cosine to the third, etc. All of that is true for our functions. Alright, I hope you enjoyed. I'll see you on the next one. Well, you'll listen to me on the next one.